Welcome to part 2 of the Algebraic Connections study guide. This is about writing equations of parallel and perpendicular lines, which y'all is just going to come down to slope. Perpendicular lines have opposite reciprocal slopes, and parallel lines have the same slope. So, let's consider the line y equals x and a point 4, 5. Here's a picture of what it should look like. If you click on that little hyperlink, you'll get the same picture. What we're going to try and do is find the equation of that line, that blue line, and we are going to find the intersection point and then calculate the distance. So here's my sketch of the line y equals x. The slope of that line is just 1, right? The coefficient of x. So the point 4, 5 would be about here, and I need a perpendicular line through that point to the line y equals x. I know that the slope of this perpendicular line, because of opposite reciprocals, if the slope of the original line is 1, that means the slope of the perpendicular line needs to be negative 1 over 1, which is just negative 1. So this new line has a slope of negative 1. And I'm going to try and come up with the equation of that line by writing y equals mx plus b. I just figured out what the m part is. I need to figure out what the b part is. How do you figure out the b part? Well, you just find an x and a y coordinate that go together, and you plug it in for x and y in that equation and solve for b. So in this case, x is 4 and y is 5. When I plug that into the equation and solve, we add 4 to both sides, it looks like the value of b would have to be 9. So there's the equation of my second line. That perpendicular line has to have the equation y equals negative 1x plus 9. The next step is trying to figure out where those two lines intersect. So I've got two lines, they're both equal to y, they're both set to y equals, so I think the easiest thing to do is just set those equations equal to each other. So I'm going to take my y equals x, and I'm going to take my y equals negative x plus 9, set those functions equal to each other, and solve. Add an x to both sides, 2x has to equal 9, so x has to equal 4.5. The corresponding y coordinate, all you have to do is you can plug it into either one of these equations, but it's really easy to plug it into the line y equals x. If x is 4.5, y is the same thing. So there's my intersection coordinate, 4.5, 4.5. The final thing to do would be to calculate the distance from that point to the line, which I know the closest point is at 4.5. So I'm just going to use the straight up distance formula to figure out how long that segment is. The distance in the x direction, difference between 4 and 4.5 is 0.5. The distance in the y direction is also 0.5. So I'm going to take 0.5 squared, add another 0.5 squared, and together that adds up to 0.5. So the square root of 0.5 is the distance that I'm looking at, which is, my calculator tells me, is about 0.707. All right, now we're going to move on to the second question that's asking the same thing, it just doesn't have all the intermediate steps. All right, calculate the distance from the point 9, 8 to the line y equals 1/2 x. So that's what we're going to try and do, figure out the length of that blue segment. It's perpendicular, so we're going to need to do all the same steps. We're going to need to find the point of intersection, get the equation, and then calculate the distance. So here's my line y equals 1/2 x. The point 9, 8 lives about there. I'm going to need to find a perpendicular line that it is a part of. So let's do that. It's going to be y equals mx plus b. I just don't know what m and b are yet. I do know what the slope is going to be, though. The opposite reciprocal of 1/2 is negative 2 over 1, which is just negative 2. So the slope of this perpendicular line needs to be negative 2. I can plug in my corresponding x and y values. So x would be 9, y would be 8. When I solve that to figure out what the y-intercept is, looks like the y-intercept would have to be 26. So there's the equation of my perpendicular line, negative 2x plus 26. All right, so let's find out where those two lines intersect. I'm going to take my y equals 1/2 x and my y equals negative 2x plus 26, set those y's equal to each other, and try and solve. How you solve that equation is up to you. I'm a fan of canceling fractions, so I'm just going to double everything to kill the fraction first, then solve it the normal way, plus 4x plus 4x. 5x would have to equal 52, so x would have to be whatever 52 over 5 is, and looks like it's 10.4. To get the corresponding y value, you can plug it into either one of those two equations. I'm probably just going to plug it into the left one, the 1/2 x, because it's easy to take half of 10.4, 5.2. Maybe it's worth noting that if you plugged x into that second equation, you get the exact same value. Alrighty, so now we're going to calculate the distance from the point to the line. The distance, let's see, in the x direction, it's the difference between 10.4 and 9. In the y direction, it's the difference between 8 and 5.2. So I'm going to take each of those differences, I'm going to square them and add them together. So 1.4 squared and 2.6 squared, 9.8. So I'm looking at the distance being the square root of 9.8, which my calculator says is 3.13. And there you go. That's the distance from the point to the line. The perpendicular distance is the shortest. Thanks for watching. See you in part 3.